I want to go over some programming I just wrote for this air handler right here. And the original programming just wasn't working well. You can see the kind of craziness in the control. Let's see. Yeah, I'm not going to deep dive into that, but you can kind of see the sort of control issue that I was battling. So there were a few things going on, but what I want to get into is the programming for the Economizer, because, and I understand the reasoning for this, and I'm not trying to throw it under the bus, but what they were doing is cutting off the cooling coil when Economizer is enabled and waiting until this reached 100%, which can be fairly slow because they had a limit on the opening rate. And by that time, the discharge air temperature had gotten out of control, and then the cooling coil was having a hard time catching up. All right, so obviously there's a lot more to the programming than just this, a whole lot more, but this is the section we're going to focus on. Now this is just like a wiring diagram, except with logic and conditions. All right, so you'll notice I have these two read points, and this is where we're going to start. Set point of measured value, and these write into this PID. Now, a PID is just a fancy program for controlling set point based on how far away from set point you are. So this P controls the aggression, I is the sum of your errors and helps to compensate, and D is like it can help predict future errors. We're leaving that at 0, and P gain is going to be about 0.5, and we can adjust this if we need more aggression. But this is what we're going to look at. So instead of cutting the cooling coil off, what we're going to do is say, okay, let's see if we can use the Economizer to drive the cooling coil to 0. And if it's driven to 0, if it's cold enough to finally do that. In this case, it's not cold enough. So I'm 100% open, but I'm still using 47% of my cooling coil capacity. But if it is cold enough and I'm able to drive it to 0, what happens is this status equals 0, this becomes true. Now, after this becomes true, 3 things happen. This switches, and this latch is activated. So when this and this switch, what this is doing, see, once the cooling capacity becomes 0, we can no longer control off of this, because what your PID needs is some value within a range, okay? And there's not -% on this. So what I need to do then is control for discharge air set point and look at discharge air temperature, which is kind of what I want to do anyway. So this is going to provide a little more fine-tuned control once I drive this to 0. Also, this trigger activates this becomes true, and then my release becomes false. So if I'm no longer released here, I am going to write at priority level 8 the cooling capacity to 0. So this is like a latch. It latches the cooling capacity at 0 when it reaches 0, and that's going to give my Economizer a chance to try to maintain. But if it cannot maintain, then this is going to take effect. What's going to happen is if the discharge air temperature reaches 2 degrees more than the set point, we are going to cancel our latch. So this will then become false again, even if this is true. And then we're going to wait 2 minutes, because I still, I'm giving the Economizer some time to take control and bring this back down. But if it can't, then this goes to false, I release my cooling capacity from 0, so the cooling starts to take effect again. Now there's one more part of this program. So if the status is at 0, it activates all this. Or if my discharge air drops 3 degrees below set point, then after a 30-second delay, this also becomes true. And so it will cut off the cooling and activate all of this. And the reason this is in place, and I can fine tune these values, but if it's very, very cold out and my discharge air temperature just plummets, then I want to go ahead and cut off my cooling, and I want to get the economizer right away looking at the set point and the discharge air. Okay, so that's the basic idea in this, and I've tested it out. Works really good. I really like it, although you know, it's normal to have to tweak stuff as you're looking at the actual operation, but this is a big air handler, and we don't want to make rapid aggressive changes like cutting the coil off right when the economizer cuts on. Like, that doesn't make any sense, especially in the spring. It just causes these wild oscillations, whereas this is working with the cooling coil and only cutting it off after the cooling coil itself, through its own PID, decides that it's not needed. Let's look at some results here. Previously, I cleaned up all the wild oscillations going on here where I wasn't able to maintain set point and the cooling capacity was hunting all over the place. You can see that that has stabilized. Then I had to deal with this issue here of the economizer opening and closing rapidly. Okay. Now, I went into another part of the program to keep it from opening to 100% as soon as it was enabled, but without that control, we just weren't using the outdoor air to full advantage for cooling. And so these are the new changes where you can see my outdoor air is helping with the cooling. My cooling valve is stable, so this is gonna, you know, when you're cutting out oscillations, not only are you improving the control, but you're reducing the wear on components. And I'm able to maintain set point really well. So this program, along with some previous changes, has drastically improved all of this garbage that we were getting before. Hope it was interesting. Like and subscribe. Check out all my links. Connect with me on Discord and all that good stuff. And I'll see you all in the next one.